All right, let's talk about the spherical coordinate system. All right, so let's say you have a point in three-dimensional space. So I'll just put a random point there. All right, then I'm just gonna connect that dot with the origin. All right, so distance there, the length of that blue line segment is going to be r. All right. Then what we want to do is we want to find the x coordinate, y coordinate, z coordinate in terms of r and theta, and they're going to be phi. Alright, the theta is going to be the angle this blue line segment makes with the z-axis, positive z-axis. So this is going to be theta right there. Alright, then we're going to project this dot down to the xy plane, and maybe somewhere around there. Right, then connect that with the origin again. Right, the angle that makes with the positive x-axis, so that's going to be called phi. Right, so let's try to find the first one is a z coordinate. So if you look at the z coordinates, I'm gonna just oops, maybe I'll use the blue dots here to the z coordinate. Right, so you can kind of visualize this right triangle here. Let's see, that looks okay here. Alright, so we can do r times cosine of theta will give you this value right here. So this is going to be r times cosine of theta. So z value is simply r cosine theta. So I'm just gonna write that down. So this is going to z value is r cosine of theta. Alright, then r sine of theta would be right here. So r sine of theta, right, which is the same thing. Maybe I should write it here. So this is the same length, r sine of theta. And if you want to find the x coordinate, you would have to go here. Then again, you can visualize the right triangle there. So you can do r sine of theta times cosine of phi. So r sine of theta cosine of phi would give you the x coordinates, and similarly if you want the y coordinates, so you can just go, whoops, don't need that, and they go here. Then r sine of theta sine of phi would give us the y coordinate. So these are the convergent equations, right? Then if you want to find the volume element for spherical coordinates, and I'm gonna draw another picture here. So let's say you have maybe I'll draw x-axis here and a y-axis here and a z-axis there. Alright, then we're talking about a tiny piece of theta, tiny piece of phi, and a tiny piece of r. So let's see if I can draw this. Right, so tiny piece of theta, so this is gonna be like this and like that, and a tiny piece of phi, let's see, it's gonna look like that, and so I would say it's gonna look kind of like this. Right, so maybe I'll just may turn that into a solid. And so something like that. So here. Alright, so let's try to see if we can find the volume element for this guy. So I'm gonna just paint a little bit so that you can see it. So this is alright, so that's that. Right, so alright, let's find the length here. So easy one would be right here. This is just a little piece of r, so this is going to be dr, so that's no problem. Right, then another thing is here. Right, this is going to be actually maybe let's do here. Right, so this is going to be a d theta, so times r will give you, so r d theta would give us this. Right, then if you want to find this guy, so this is a little bit a little piece of a phi, so d phi, then radius is r, so r d, oh actually I messed it up a little bit there, yeah, right, maybe I have to, let's see here, I have to project it down, so down to here on the xy plane. Right, then it's going to look somewhat like this. Right, so in order to find the length here is actually we have to look at here. Right, so length there is r sine theta, just like before, r sine theta. Right, then you want to little piece of phi here. So this length right here is actually r sine theta and the d phi, right, which corresponds to this length right here. Okay, so this is r sine theta d phi. So if you want to find the volume element dv for the spherical coordinate system, you would have to do, let's see, there's two r's, so it's going to be r squared, then there's going to be a sine of theta, right, then you have dr, d theta, and the d phi, right. So this is the volume element in a spherical coordinate system. So it's dv is equal to r squared sine of theta dr d theta d phi. Right, that's it. I hope that this was clear.